This is the second video, Series versus Parallel Circuits Lab 2. In the previous video we did steps 1 through 10. Alright, and now we're going to do steps 11 until the end. So in step 11 you're supposed to create this circuit right here, and I've already done that in our circuit simulation software. So there it is there. So I'll turn the switch on so that the current is running through the circuit, and then we'll move to step 12. Step 12 says measure the current in the circuit and the brightness of the bulb. And we go back to our software here, you'll notice that the current in our ammeters is 0.9 amps. Okay, and our brightness of our bulb is kind of average there. Step 13 says add a second path to the circuit with another light and ammeter. So it's supposed to look like this. So we'll try and do that. So I'm going to shift this over. I'm going to split that junction there, and we'll just shift everything over here to create some room for ourselves as well. All right. So we'll add another pathway here, and I'm going to go back and just check that. So we need ammeter, then light, and then back down to the bottom of the circuit. So let's take an ammeter and put that in there. Just shift it up just a little bit. Add another wire. Right, like that. Let's split that junction there. So we can add a wire to that second path that we just added. So there, like that. And then we'll connect those two together. And now we need a wire to go from here to there. So we'll add that. And there we go. So now both paths are working, so we're creating a parallel circuit. Step 14 says measure the current in the circuit and in each path. So the current coming out of the battery is 1.80 amps. The current in the first path is 0.9 amps, and the current in the second path is 0.9 amps. So that's the information we're going to write right here in step 14. Step 15 says add a third path to the circuit with another light and ammeter. So let me just kind of shift the parts of the voltmeter out of the way, and we'll add another path. So we'll add this, another wire, and another wire to create our path. We'll add our ammeter and a wire that will go from the ammeter to our light bulb. So there we go. And we'll add a wire that will go down from the light bulb to the main pathway. And there we go. All three pathways are now working. So step 16 says measure the current in the circuit, and in each path note the brightness of the bulbs. Okay, so you notice that the brightness of our bulbs hasn't really changed that much, I don't think, but we'll look at the current first, and then we'll double check the brightness of the bulb. So 2.7 amps is the current coming out of the battery. 0.9 amps is found in each of the pathways. So that's what we need to write down here in step 16. Now I'm just going to kind of split the junctions here. So we'll split that junction and split that junction just to see how the brightness of our first bulb and the brightness of the other bulbs respond as we add the paths. So there's the bulb brightness for there. Add the next path. Again, you notice that the brightness of the first bulb didn't change. Now note the brightness of the first and the second bulb, and add the third path. And again, the bulb brightness doesn't change. So when we add the second and third pathways, the brightness of the bulb doesn't actually change. Question 17 asks, what happens to the current in a parallel circuit as you add more paths? Well, you'll notice that as we added the second path, then the third path, the current that was coming out of the battery, which was right here, increased. Okay, and then what can you conclude about how current is distributed or spread through the parallel circuit? Well, when you go back here, you'll notice that 2.7 amps is coming out of the battery, and each of these pathways is 0.9. Well, if you take 0.9, 0.9, and 0.9 and add them up, you get 2.7. So that means the current coming out of the battery is divided between each of the pathways in the parallel circuit, so that if you were to add up the current in each of the pathways, add them all up together, you're going to get a total that equals the current coming out of the battery. All right, so we'll see you in the next video, which will be the last lab we do on series versus parallel circuits.